So again, make sure that you're remembering that you list the most metallic element first. One thing you'll notice, like looking back at the examples, look at CO2. Is there even a metal in that? No, because they're covalent, right? But look at C and O on the periodic table. Which is more metallic out of the two? Which is more to the left, the C or the O? The carbon. So it is the most metallic. Look at silicon dioxide. Which is more left, silicone or oxygen? Silicone is. So the most metallic is listed first. Did we all catch that? Yes. Okay. K2S. Channing, what'd you get? It's okay. Because K, potassium, is for sure a metal, right? Bailey, what about NO3? Very good. Because you only have nonmetals there. And Jennifer Estrada, what'd you get for KCl? What? What? Ionic? Because K is what? Potassium, and it's a metal, right? So I think the big thing here really takes us back up to the previous question. How do you tell if you have an ionic compound? An ionic compound is going to have a metal involved. Covalent compounds are going to lack metals exclusively. We cool? Better? Okay. Let's move on. I want to talk about one more thing, one more piece, and that is a special type of, or for a special type of stuff, something called the polyatomic ions. So you can title this polyatomic ions. I know a lot of you have taken geometry along the way, or you're in it right now. What does a polygon mean? What does poly mean? Many, and polygon is many-sided figure, right? So what does poly mean still? Many? Many atoms? And what is an ion? From our last unit. Very good, a charged particle. So this is when you have many atoms with a charge. You have seen monoatomic ions before, like S2 minus, or I1 minus, or Na1 plus, or K1 plus, or Ca2 plus. You could write out a lot of these, could you not? These would not be polyatomic, they are monatomic ions. And how do you know what the charge is for a monatomic ion? Where do you look? At Mr. Fields? What? On the periodic table, right? Okay. There's some polyatomic ions that you have to know. Here's a listing of some of the ones that you do have to be familiar with. NH4 1 plus. Do you see how many atoms are in this one? How many N's are there? There's 1. How many H's are there? 4. So there's 5 atoms there, and it's having a charge. The name of this is ammonium, NH4 1 plus. You have to know this next two. NO3, how many atoms do you see there? 4. NO3 has a 1 minus charge. It's called nitrate. It has a very close relative, NO2, with a 1 minus charge. That's called nitrite. There's SO4 and SO3, both with a 2 minus charge. Sulfate and sulfite. Those are very common polyatomic ions. The list isn't complete though. There's a couple more that I think we should go over. PO4, which has 5 atoms in it, carrying a 3- charge, is phosphate. MnO4 with a 1- charge is permanganate. So you see right here that you have several polyatomic ions that you have to be familiar with. You don't have to memorize them, but you do have to be mindful that they are there. This list is not complete. There's some more that we're going to talk about in just a second. So we can add some more to this list. But you can realize they're all polyatomic ions. Now let me ask you this question real quick. Would you expect these to be in ionic or covalent compounds? Look at the name. What are they called? Polyatomic ions. Do you think they're in ionic or covalent? Okay. So we could write down that polyatomic ions are found in ionic compounds only. Let's add a couple more to this list. C2H3O2-. One is called acetate. CO3 2- is carbonate. ClO3- and ClO2- are chlorate and chlorite. CrO4 with a 2- is chromate. Cn1- is cyanide. Cr2O7 2- is dichromate. HCO3- is hydrogen carbonate. ClO4- 1 is called perchlorate.